Hi everyone, welcome back to our series on AI 900. So today in this video we are doing some hands-on exercises. So in this video we are doing the automated machine learning in Azure. So we are doing AutoML in Azure. We use the automated machine learning services. Before dive into the hands-on exploration, let's quickly review some of the fundamental concepts of machine learning. So which will kind of help and set the stage for today's session. So machine learning is a powerful tool, as we all know that it's used to build predictive models for past data, and it allows us to forecast the outcomes and makes data driven decisions. So main machine learning, it's the core behind most of the AI applications. So nowadays AI is taking over, so the basic core concepts of AI is inside the machine learning, and can be this machine learning is categorized into two kinds of thing. One is supervised and another one is unsupervised learning. So we can explain in such a way that in supervised learning we can predict outcome based on the labeled data, such as regression, using the regression method, predicting the numerical values, and the classification method by predicting some categories. So in the unsupervised learning, it helps us to identifying the hidden patterns. Like it identifies the different kind of clustering methods, using different kinds of clustering method, and identifies the patterns in the data. So these are the two broader classification of machine learning: supervised and unsupervised. Later on we also have some knowledge about deep learning. So in AI with the machine learning and deep learning, it also evolves in the AI. So AI in deep learning, we usually use the neural networks to handle more complex tasks like image processing and natural language processing, image recognition. So these things is done by the neural networks of deep learning. So this is the whole idea about. Uh, we can say that it's kind of an overview of the machine learning and AI. So I have attached a summarized document in the description of this video. You can check it out for more kind of summary of machine learning and deep learning and supervised and what is unsupervised learning. I have added some points in that document. You can check it out. So let's focus on this video. So in this video, we will focus on a feature of Azure Machine Learning that makes it very even easier to develop machine learning models. So one of the feature of Azure is Azure AutoML, which is automated machine learning, and it simplifies the process of automatically selecting the best algorithms and parameters from our datasets, and which helps us to train, evaluate, and deploy the machine learning models. It also tests the machine learning models without having to write complex code. So it's kind of automated the machine learning process. So Azure provides us this feature known as Azure AutoML. Azure AutoML. So hope this brief introduction kind of thing helps you out to understand what is Azure AutoML. So let's move on to the hands-on part where we will walk through using Azure AutoML to build, deploy, and test a machine learning model. Let's get started. So log into your account. So if you don't have any subscription, so try to create one. So in my account, I've created this account new. So I have the free trial account. So in the free trial, I'm going to do the hands-on of today's video. So just go to the home page, home console. So in this demo, in this hands-on, what we can say, we used a public data set of the historical bicycle rental data, which is provided by the Microsoft itself. And we train a model based on top of that, and we predicts the number of bicycle rental which is expected on a given date based on the seasonal and meteorological features which we are inputting as in data, and we are predicting the number of rental cycles in a day kind of thing. So for that we use the Azure automated machine learning service. So to use the automated machine learning service, first we have to create Azure machine learning workspace. To create the machine learning workspace, you have to go to the create a resource button, click on it, and just type Azure machine learning and click on it. You will be able to see this Azure machine learning. Just go to its create and click on Azure Machine Learning. So here we have to create a machine learning workspace in the Azure Machine Learning. So for that we have to enter some configurations. So we are using the subscription as free trial. If you have different subscription, it will cost a little bit because it uses the compute power and different things behind the scene. So we have to use the subscription. I'm using the free trial. You have to choose the resource group. So if you know what is resource group, so it is a collection of resources that shares the same life cycle, permissions and policies. So we created this resource group, and if you're trying to create multiple resources in Azure, we are using this resource group only. So for this hands-on, we created a one new resource group known as AutoML RG, AutoML resource group. Click on OK. After that, we have to set the workspace details. Name it something like AutoML workspace, AutoML demo, AutoML demo workspace. So choose the region which will be near to your area in which you are residing. So I'm going with the South India. You can also go with the Central India and South India. So I'm going with the, let's choose Central India. So to create the machine learning workspace, it needs three more resources. One is the storage account, key vault, and application insights. So this storage account, we all know that it's the default data store for our workspace, which we used in this machine learning workspace. The key vault is nothing but the way where we can store the secrets and other sensitive information which we needs in the workspace. So this is the key vault, this is storage account. Application insights, when we create some Azure application insight to store the monitoring information about our deployed models, so we use that for the application insights. And this is there is one more thing, which is container registry, which is kind of optional. It is when we use some Docker images which we use to train our model and deploy our model as in Docker images. So we don't want this container registry right now. So you can see that it's these three services, it's automatically named some new name with the which is similar to this one. After doing these changes in this page, click on next networking tab. Go with the public one, go with the default one, click on next encryption. We don't want any encryption right now, so just click on identity. Go with the default section in this identity section also, as we get the access of Azure account with the credential based access. Click on next tags. In the tags, we just put some tag right here, like we are doing this project, and name it as AutoML. So we can use this tag to tag every resources which we created in later part of this hands-on. So just tag this and click on next review and create. After you click on the review and create, it will validate all the configurations. So you can see that running final validations, and you can see that validation is passed. So you can now create the Azure Machine Learning workspace. Just click on create. So this creation of the Azure Machine Learning workspace will take 2 to 3 minutes, and after it will create it, we will be back. After 1 or 2 minutes, you will be able to see that your deployment is complete. So just click on go to resources, and you can see that the AutoML demo workshop machine learning workspace is created. You can see the configurations right here. So we have to, now we are going to use the studio web URL. This is the machine learning studio which is developed by Azure. Just click on this. If you are facing any kind of error, so just click on refresh, it will be gone, I think. Yeah, you can able to see that this is the workspace which we are created, AutoML demo workspace. If you can go to the all workspace section, you can see that different this is our recent workspace, and we have different options also available in Machine Learning Studio. So we are just going to our workspace, AutoML demo workspace. In this AutoML demo workspace, we are going to use our data and we train our model, and then we deploy that model and we test it our model. So for that, go to the authoring section and click on automated machine learning. To create this, we have to create a new automated machine learning job. Just click on that. In this job, we have to define some job name. So let me just rename it as demo. So we are using the bike rental. So it's kind of cycle, how many bicycles how many bicycles in a day are rented from a rented kind of thing based on the climatic conditions basically on a particular day. So we are using the bike rentals data which is provided publicly. So I'm just naming it as bike AutoML, provide it a name, experiment name. So I'm just demo bike experiment, or we can say demo bike rental, because we can also provide some description to it, like it's kind of automated machine learning system for the bike rental prediction. And if you want to add some tags, you can add some, like it's kind of project AutoML add, and click on next. Next you have to choose the task type, because this is the prediction of continuous numerical values in which we predicted the how many bicycles are going to be rented in a day kind of thing. So this is kind of numerical values, we are predicting the numerical values. So we are going with the regression class task type. So just select the regression. Now we have to choose the what data we are using. So for the data, I have provided the link of the data where you can download the zip file and you can extract it in your local system. So I have extracted the file in my local system. I just created the data. So you have to just click on create, set some data asset name. You can type it as bike rental, add some description if you want, like it's kind of historical bike rental data, and choose the type. If you are using my data, choose the table ML table and click on next. Next you have to upload the data. So we are using the local file, just choose this one and click on next. After that you have to choose the data store where you want to upload that. We want to store it in the Azure blob storage which we created earlier. So this is the Azure blob storage which we created earlier. So just choose that and click on next. Here we have to upload the ML table files and the folder which we extracted. Just go to this, and this is the bike data which I extracted. So just upload it. It says that there are two files in this folder. Upload all these two files and click on next. In the next page you will review the data asset for, configuration and create the data asset by clicking on the create button. So it will create the data asset. It will create the data assets. You are now able to see this data, and we have to select a data. So we created one data and we select it, and then we use that data for our model automated machine learning job. So just select this and click on next. After the task type in data, we have to set the target column from the data. You can also view the data by clicking on this. You can see that these are the columns available, and this is the profiling of the data. So we have to choose the target column from here. So next we have to set the target column. So what is our target column which we want to predict? So just select the column of rental, because we want to predict how many bikes in a day, how many cycles are in a day is going to be rented. So just choose this rental column. After that, click on view additional configuration settings. Here you have to set the primary metrics. So I'm just choosing the normalized root mean squared error, and unselect these two things, explain best model or use all supported models, because we are just using few models, because it will take some time. The ML job will run and it will take around 10 to 15 minutes to completed the job to be completed. So unselect this and allowed. After that, click on the allowed models. Here we are only choosing the random forest and light GBM model. These two models we are choosing, and click on save. After that, you will be expand this limit section right here and set some configurations right here. I am setting maximum trial as 3, maximum concurrent trial as 3, maximum node as 3, maximum metric score threshold as 0.085. It's kind of threshold that if a model achieves that a normalized root mean square error matrix of 0.085 or less, the job will ends right up here. So experiment timeout has to be 15 minutes, iteration timeout should be 15 minutes, and enable the early termination if possible. Let me just 15 minutes. So for the validation and testing, we will split the data into training and validation split in the 1:10 ratio, 10% for the validation data, 90% for the training data. And we don't want any test data to be split. So these, after setting all these things, click on next. Now we have to choose some compute power. So we are going with the serverless architecture, choosing CPUs, dedicated CPUs, and in the virtual machine, choose the DS3 V2. This is the virtual machine size I am choosing, and the number of instances 1 to run this job. After doing these changes, click on next. In the last page, you will be able to see the review all the configuration which you have set for the ML job, and after that you have to click on submit training job. So it will start submitting the job and start the job. Our job is, you can see the status, it's not started yet, but after a few seconds you will see, after clicking on refresh, or it will automatically refresh itself, you will be able to see that the status comes out to be running instead. You can see that it's starting now. So at first it will create all these things like setting the data assets and uploading all these things to the data blob storage, and after that it will status. After that the job will start doing its job. You will be able to see that it's now running. So now it will take around approximately 10 minutes to finish the job. So see you after 10 minutes. So after 10, after approximately 10 minutes, the status change to be completed. So our automated machine learning job basically completes right up here. So we have some, click on this overview button. So on this, which you are earlier, and we are now reviewing the best model after this. So here you can see a section best model summary, and this is the algorithm name which comes out to be the best. So you can just go to the bike rental thing, and these are the other summaries like run summary, task type, and all the thing. These are the tags which it performs. You can just go to the click on this voting in symbol. So this is the algorithm name which comes out as the best model for this data which we provided. So you can just go to the you can just go and review all its other matrices. So just go to the metrics tab and review the model. So for the reviewing part, we just use this predicted true metrics, which shows us that how much the predicted value and the actual value is differacting, so, using the graph. So there is one more matrix known as residuals. So it shows how much deflection is there in the actual value and the predicted value. So using these two metrics, you will be able to get the data about how your model behaves, how how accurate it is, basically, kind of thing. So now after reviewing the model, we are just going to deploy this model and test it out for our use case. So for deploying the model, we have different options like real-time endpoint, batch endpoint, and web services. For now, we are just deploying it on local machine, so kind of local setup. So for that we have to download this model which we just created. So it will download it in a zip file. You can able to see that. You have to extract this zip file. Just so in the zip file we have this conda YAML file, model pickle file, and this Python file. So we are going to use this model.pickle file, and we are creating one more file, requirement.txt file, to basically use it accordingly to deploy our model in our use case, to which is going to run in our Colab notebook. So this is our Colab notebook. You can just create it on your Google account. Basically, you just go to the Google Colab.research and it will automatically connects uh, with your drive, and you are able to get this notebook kind of thing, which basically connects with your local runtime, basically your local system. So for that, in this environment, we are going to deploy our Azure AutoML model. So to use this model to use and deploy and then test it out, we have to upload the model file and the requirement.txt file. So I will provide you the requirement.txt file in the description below, so that you can edit your requirement.txt file according to that. So let's just go to this form.google colab import files and run this first cell. So this will upload the model.pickle and requirement.txt file. So just choose these two files from your local systems and upload it. After that, after your uploading of the files is completed, next you have to run the requirement.txt file, so that it will downloads all the requirements. So I have run this requirement.txt file quite a few times, so it's in my case it's showing already satisfied. In your case it might not uh, come as same, because it will download some of the requirements basically. So after that, if this commands completes, you have to you have a pop-up like restart your session, because some of the packages are updating and installing the earlier one. So that's why it's kind to it's gives us the pop-up as a restart the session. So if you have that option, click on restart the session. So, for showing you, I'm just restarting the session of mine also. Let me just restart the session. Go to the runtime and click on restart. Restart the session. Yes, you can see our Google Colab notebook is going to restart the session. So after restarting the session, just go to the next step. So our model is uploaded in the notebook. Now we are going to use this model by loading it into the model, and then we can use, you can test it out by giving the inputs, and we are predicting the outputs. Model.predict. So this is the code in which we are loading our model and then predicting the values. We are passing the input values in a data frame kind of structure. You can see right here. So we are going to run this cell. So you can see that in this we have only one input value, but we can, because it's kind of data frame, so we can also provide multiple inputs at one time and we can get the output. You can see that the output comes out. So on the 1st of January 2023, total 306, approximately 306 bicycles are rented basically on the data which we train our model basically. Let me just change this data to 2022 and just hit. Yeah, so on in 2022 it's kind of 365 bikes. So in this way we can deploy the AutoML model. You can also use the endpoint method also on the Azure portal itself. That costs a little bit of money from your Azure account, so that's why we are using the local one. And here we are able to see the, we are able to deploy and test it out, our model basically, model.pickle file, which we generated using the model is created using the Microsoft Azure automated machine learning services. So in this video, that's it for the whole hands-on part here. And don't forget to remove all the resources which you are created. So just go to the Azure setup thing, go to the home and go to the your subscription, the demo MLRG, and just delete this resource group, so that if you don't delete this, it will cost a lot. Like if you are not in free trial, and otherwise your free trial ended, and it will cost a lot of things. So it's a best practice to clean up all the things. And if you are creating the endpoint using the machine learning from right up here, real-time endpoint, you have to go to the endpoint section and then delete the endpoint from here. Like this is the one, like delete this one, so that you don't have extra cost regarding to that. So it's kind of deleting. So hope you guys like this hands-on exercises on our AI 900 series. This is the first video. We are good to go with the next upcoming videos. So hope you guys like this video. So don't forget to subscribe and hit the bell icon for the next video. Thank you.